The lining of the small intestine, like the lining of most of the gut, is a single-layered epithelium. Depending upon location in the gut, the epithelial cells, usually called enterocytes, help absorb nutrients from the lumen of the gut, or absorb water from the intestinal contents. In the small intestine, the surface of the lining of the gut is increased enormously by thousands of villi that protrude into the lumen. Here we see a single villus and its internal architecture. The surface of the villus is covered by a single layer of enterocytes, which extend down into the crypt below. Stem cells at the bottom of the crypt, located between Paneth cells, divide and make copies of themselves, and also make transit-amplifying cells. The transit-amplifying cells proliferate rapidly and move up the walls of the crypt. As the cells migrate upwards, they begin to differentiate into goblet cells and enterocytes. While the cells are moving up the sides of the villus, they carry out the essential functions of the small intestine, notably absorption of nutrients. When the differentiated cells reach the tip of the villus, they undergo apoptosis and are shed into the lumen of the small intestine. The entire process of outmigration and cell death is completed in just 3 to 4 days. The process of outmigration and rapid cell replacement is a defense mechanism against the development of colon cancer, since almost all epithelial cells, including those that have accidentally sustained mutations, are shed within days of their formation. Therefore, the only mutations that can lead to the development of a cancer are those that are retained in the crypt. This dictates that such mutations must block the outmigration of mutant cells from the crypt. The outmigration of transit-amplifying cells from the bottom of the crypt depends on the protein called adenomatous polyposis coli, or simply APC. In the absence of functional APC, this continuous outmigration is blocked, leading to the accumulation of transit-amplifying cells in the crypt. In this animation of an experiment, APC loss is achieved through an induced gene inactivation, which appears to mimic the mutation that initiates most gastrointestinal tumors. APC is usually required to inactivate the intracellular protein called beta-catenin. The inactivation of beta-catenin permits the differentiation of the transit-amplifying cells and their continued outmigration from the base of the crypt. In the absence of APC function, beta-catenin accumulates within the transit-amplifying cells, which blocks both their outmigration and their differentiation. The accumulated transit-amplifying cells do not themselves form a carcinoma. However, they and their descendants can now accumulate additional mutations that will drive such cells progressively to become full-fledged carcinoma cells.